In this video, we are going to see about amplitude modulation and demodulation. So why we go for modulation? Modulation is necessary to transmit the low frequency signal to a long distance. And we have three different types of modulation, that is amplitude modulation, frequency modulation and phase modulation. Amplitude modulation is nothing but changing the amplitude of the carrier signal in accordance with the instantaneous value of the modulating signal. That is amplitude modulation, right? So here actually we have the amplitude modulator and demodulator circuit. In amplitude modulator circuit we have the transistor, and this transistor can act as a mixer or otherwise product modulator. This is nothing but product modulator, right? And this transistor just mixes the modulating signal and the carrier signal, and it produces the modulated signal at the output. So here actually in this trainer kit we have three different parts. One is signal generator for message and the carrier signal, and another one is modulator circuit, right? And here the modulator circuit, we are going to apply modulating signal at the emitter terminal and the carrier signal at the base terminal, right? And we are going to take the output at the collector. So these are all the nature of the output waveforms based on the modulation index value. In the first case, the modulation index value is less than 1, right? Already modulation index, how we are going to calculate the modulation index? The modulation index can be calculated by using this formula, M is equal to Em by Ec. Em is nothing but amplitude of the modulating signal, and Ec is nothing but amplitude of the carrier signal, right? So when under modulation, during under modulation, Em value is less than Ec, right? Em value less than Ec, so we will be getting both E maximum and the E minimum, right? This peak to peak value is the E maximum, and this peak to peak value is the E minimum, right? And in the second case, critical modulation, MA value will be 1, right? In this case, Em is equal to Ec. Amplitude of the modulating signal is equal to amplitude of the carrier signal, right? So in this case, there is no Em, there is no E minimum, right? We will be having only E maximum. Only E maximum will be present in the output waveform, and E minimum will be 0. For over modulation, the E minimum will overlap to each other. The tail end of the EM modulated wave will be overlapped to each other. So in this case, at the receiver side, the filter just cuts the tail end, so we'll be getting distortion in the reconstructed signal, right? So over modulation is not at all preferred in the for practical applications, right? So among these three modulations, only under modulation is preferred, right? So now we are going to observe the output waveform. So first let us see the case of under modulation. So for that the message signal amplitude is 4 volt. Now I am going to say the amplitude of the message signal as 4 volt and the amplitude of the carrier signal as 12 volt, right? And in this case Em value will be 4 volt and the Ec will be 12 volt. So we are going to calculate the modulation index. It is equal to 4 divided by 12, it is 0.33. So it is less than 1, right? That is why this kind of modulation is nothing but under modulation. Now for over modulation, I am going to adjust the amplitude of the message signal, and this message signal amplitude must be high when compared to carrier signal, right? So in this case, I am going to fix to a 16 volt for amplitude of message signal and 12 volt for amplitude of carrier signal, right? And in this case, if you are going to calculate the modulation index, M is equal to 16 by 12, it is equal to 1.33. So it is greater than 1, right? The waveform will be like this, right? So in this case, there is overlapping, right? Overlapping at the tail end. We don't have any E minimum. E minimum value will be there, but it is mixed up with the tail end of the other adjacent waveform, right? So E maximum will be there and E minimum will be overlapped to each other. So this is a circuit for demodulation, right? Here actually we are going to make use of AM diode detector. Here actually there are three components. One is diode, resistor and a capacitor. This diode just converts the upper side one and lower side one into single side variations, and this RC network just forms the filter and it just removes the unwanted components and smoothens the demodulated signal, right? So at the output of this circuit you will be getting the reconstructed signal, right? So by this way we are going to demodulate the original information. So this is the output of AM detector, right? Here actually the original signal is reconstructed with the help of AM diode detector, and we will be getting the reconstructed signal at the output. So here actually we have to note down the amplitude, number of divisions along y-axis and number of divisions along x-axis for complete cycle, and we have to note time per division and the volts per division for the calculation of amplitude as well as time period. And by using amplitude and time period, you can draw the graph, right? You can plot the demodulated signal in the ordinary graph.